Welcome to this video on catching errors. In our first example, we'll demonstrate how we can catch a division by zero exception before it occurs. The function sin x divided by x is not defined at x equal 0. If we calculate f of 0, we'll get an error. This expression is divided by 0. It cannot be computed. Since the limit of sin x over x as x approaches 0 is 1, it would make good sense to define a new function which acts as sin x over x, but returns 1 when evaluated at x equals 0. This function is officially called sincx. So to define sincx, go to the programming toolbar and select try. Here we enter sin x divided by x, and in the on error section we enter 1. Let's see if it works. Sinc of 0 is equal 1. Division by 0 is not the only error we can catch. Let's take another example where we are searching for a specific element in the matrix A. Here we are searching for the element 5 in the matrix A, and we can see 5 occurs in two places. We'll have the result returned as a nested matrix. To unnest the matrix, go to Matrices Tables tab and deselect Collapse Nested Matrices, and we'll see the positions where 5 is found. If we try with 7 instead of 5, we'll see that we have an error, no matching values found. To avoid this error, let's catch it before it occurs. So let's define a new match function. Let's see how it works. We'll just take a copy of these, place them below our new program, change the M to capital M, works as before, and here. Our final example is the Newton-Raphson root finding algorithm. The algorithm works like this. We want to find the roots of the function fx equal x squared minus cosine of x. Let's take a look at the graph. Let x equal 2 be our guess value. We'll draw a tangent at 2, find its intersection with the x-axis. It's about 1.1. So 1.1 is our first approximation to the root. Now draw a tangent at 1.1 here. Find the intersection with the x-axis. And as we can see, we are almost there after 2 iterations. To the left is the most basic implementation of the algorithm. Here f refers to the actual function, p to the guess value, n to the number of iterations, and tol is the tolerance. So here f will refer to this function, 2 our guess value, 10 the number of iterations, and here is our tolerance. It seems to work fine, but not always. Here the function is changed to 1 minus x squared, and with guess value 0, we get a division by 0 error. The only division occurs in this line. We are dividing by g of p ode. G is the derivative of f, so this means that we have a horizontal tangent at our starting point, and a horizontal tangent can't intersect the x-axis. Now let's do what we did in our first example. Go to Programming, click Try, and in the On Error section, we want to terminate the program. So choose Return and return division by 0. But we can do it better. We can give pold a little push to the right or to the left so that the tangent is no longer horizontal. So instead of the return. Let's enter pold and assign pold plus the tolerance. Add a new line, take a copy of this. Now the method will fail. That's because we have only given pold a little push, so the tangent is almost horizontal. So the intersection will be way from the root. So let's increase the number of iterations. Here we have solved one of the difficulties in the Newton-Raphson algorithm. There are several others, but they can't be solved using try on error. Thanks for watching.